Welcome to the statistics learning session. Today, we'll be again talking about a chi-square test. In this chi-square test session, we'll talk about why the correct number of degrees of freedom matters in chi-square test. Now, as a food for thought, can you think about why it matters in chi-square test, the degree of freedom? Can you think about it? Degree of freedom matters in chi-square test because, as we know, the chi-square distribution has a degree of freedom with k, and it is used to determine critical values for hypothesis test. And what are critical values? Can you tell me? Critical values are thresholds beyond which we reject a null hypothesis H naught. So what I'm saying is that the the value of k is to determine critical values for hypothesis test. Now, when you have a chi-square distribution with a k degree of freedom, the critical value will be large because distribution with more degrees of freedom have less variability. That is, higher the bigger the k, larger the critical value. Using this k degree of freedom makes test more conservative, meaning you are less likely to reject the null hypothesis. This is because if critical values are larger, then it is harder to exceed them and thus reject null hypothesis. Now, if you have a k minus 1 degree of freedom, instead, the critical value will be smaller, thus, it will be easier to exceed them and reject null hypothesis. This is because the critical value is smaller because distribution with fewer degrees of freedom have more variability. Now let's go back to our old calculation here. This is the calculation we did last time. Here, this is what we did last time. And what you see here is that what we did was Pj 1 minus Pj. This value is always smaller than Pj because when you multiply anything that is less than 1, then it is much smaller than the value itself. Now, what I'm saying here is that in this calculation, we are dividing with a much smaller value, and as a result of this is more likely to be bigger value that would exceed the larger critical value of chi-square of with k degree of freedom because this is larger. And because of this, it is more likely to have some kind of like a type 1 error because of this. Now, now let's go back to our calculation here where we have this our original calculation where we have this calculation where we divide this divide numerator by the just only one pj, and we have a k minus 1 degree of freedom. Here the value is a little bit larger here than before, and this value is a little bit smaller because, and so there is some kind of a compensation going on here. Here the value is a bit larger, but this is smaller. And so still there is some kind of like a way of to exit it much better than other one. So what is this is a chi-square test with a k minus 1 degree of freedom, and here the p-value is a probability of chi-square test distribution with k minus degree of freedom exceeds the observed test statistics. So let me quickly sum up what we learned today. We learned about the previously what we did calculation, and we learned about why the degree of freedom matters in chi-square test. The more degree of freedom you have, the higher critical value. If you have a more degree of freedom, then if they have a higher critical value, then it is less likely the test becomes more conservative, because it is less likely that you will reject the null hypothesis. But if you have less degree of freedom, then it is more likely that you will reject the null hypothesis, and because of that, it's a higher chance of having the type 1 error. So that's all for today. I'll see you next learning session. Thank you so much. Have a nice day.